Okay, so this was my first ever GFFE grant. I was just telling Sam Chiappa in the back. I started at Guilford High School in the December months, replacing a teacher who had left. And I was put into an electronics and engineering class, and it really wasn't my forte, and the curriculum, the products that were supporting the curriculum were a bit outdated, and the students were really interested. So I walked into the teacher's lounge to check my mail, and I saw this GFFE poster, and I'm like, oh, wow, this looks pretty awesome. They're willing to give me some money to support my classroom. So I put together this grant, and the rest is history. Ever since then, the Guilford Public Schools has supported this program, so the GFFE started it, and the Guilford Public Schools has continued it for the coming years. Currently, I am not teaching this course. My coworker Jim Carlson is, but to this date, this is still being implemented. So I'm sorry it's a little bit small, but what is Perch Robotics? Basically, it was started by the Office of Naval Research. They saw this trend data that showed that a lot of students were leaving high school and not really interested in engineering or math or anything along the technical side. So they started this program with the hopes of sparking interest in young children and students to get them possibly down that career path. So basically what a Perch is, it's a remote operated vehicle, about this big, and the students design it, make it, program it, and wire the entire thing to complete a certain task. Every year the Office of Naval Research comes up with a different task to complete, and it's usually linked to some sort of a real world problem. Obviously it's a little bit simulated, some things might be a little bit different, but it is connected to usually a real world problem. Through the project, students learn engineering concepts, they work in groups together to problem solve, and usually it has a particular application. So again, I know that this is small, but some of the impacts on student learning, as you can see up here in the top left, is once they make the controller, which you'll see in the next slide, there's a list of electronic kind of troubleshooting and a flow chart that they create to kind of go through to make sure that everything that they've done works properly. You'll see on the right-hand side also the idea of a basic Perch and how it possibly should be constructed to give the students an idea of the construction and the placement of the different components. You'll also see that this is done in a CAD drawing, which we also have our students do. We have them do a rough hand sketch to kind of get their ideas down on paper, and then they go ahead and they design on the computer before we give them the actual materials. The reason being is just kind of modeling a real-life resource. There's obviously a limited amount of resources. They don't have unlimited pieces of foam, they don't have unlimited pieces of PVC pipe, so they have to kind of design within those restrictions to complete the task. So if you look on the top left, you'll see a basic electrical circuit design. This is what I first started teaching when I started at Guilford High School, and we were using resistors, and we were using capacitors and batteries, and everything was really kind of simplistic because the students were just taking measurements using a regular electrical meter. What the Perch was able to do was able to take all of those theories and all that knowledge and actually put it to a practical application. So if you look on the right here, you'll see the circuit board that controls the robot. The students learn about all of those components. They also solder those all into the controller, and then they do the circuit test that you saw on the slide before, so that they're kind of doing a full-fledged problem-solving process. Some of the outcomes from this, the first year that we started this, we were invited to partake in the national championship in Washington, D.C. So myself and a bunch of students jumped on the train in New Haven, and we took the train down to Washington, D.C. And we placed third in the obstacle course, which, if you can see, is basically a large swimming pool with different hula hoops placed throughout so that they can maneuver. What's really cool about this is that it sounds really simplistic, but because the students have complete design and control of everything in the robot, there's vast amounts of different designs. We went there and some of our students were like, oh my God, Mr. Ripa, did you see that? That looks completely ridiculous. I don't think that's going to work. And then when they saw it working in the water, they were, oh my gosh, that's a really smart idea. So it was awesome to be able to go to something nationally, see people from throughout the United States and actually internationally, and be able to kind of network with them and communicate with them. Also, along the lines, we still are doing this field trip to this day. It's actually tomorrow. We go to the Groton Submarine School. Not the submarine base that's open to the entire public, but the actual school that's across the street. One of our students, when we first started this, his father worked at Electric Boat, and he was able to get us a connection at the actual sub-school. So the students are able to go there, see what the submariners do, understand about the control of a real submarine, and then we can kind of relate it back to the ROV that they create. So what you're seeing on the right here is a sub simulator that is used by the actual submariners. Have a couple of our students driving it, a couple holding on, a couple kind of doing the different controls. But it pitches up to about 30 degrees and down to about 40 degrees and kind of maneuvers all in between. So these are some of the things that we were able to do because of this grant, which is awesome. My final thoughts for this is basically just to keep innovating. Herb and I have constant conversations about new things that are happening in technology and new things that are happening in education. And I always think to myself, I don't know how like a teacher could do the same thing for 40 years, because it's awesome to be able to come every year, try something new, bounce ideas off your coworkers, and kind of figure out what keeps the students interested. So that's kind of where I've been.